In this question, we're gonna practice recursive programming one more time. And this is the exercise we have here. We're gonna print the digits of an integer in reverse. So here is our function. We're gonna do a recursive function, obviously. So if we call the function with this integer, this will be the output. We're gonna print the digits in reverse, and let's also separate them by space, since we're gonna extract the digits out anyway, so we can separate them by a space. So let's start by thinking about this question in a recursive approach. What does it take to produce this output? So here is a function call. If we call this function with parameter 234, typically we want to do an action, maybe couple actions, excuse me, a bunch of lines of code, and eventually we're gonna call the p again, right? Because when we are solving a recursive function, we usually solve a part of the problem. We don't solve the problem all head on. We solve a part of the problem, and then we call the same function, hopefully with a smaller parameter, right? The parameter keeps getting smaller and smaller until we solve the full problem. Sometimes there may be even action after the recursive call, but the bottom line is when we call p to print this guy in reverse, it's gonna do a little bit of work and then call p again. So let's try to find out what kind of action would this be. So if I call p with 234, that's the first thing that I want to be done, printing the 4, and we can easily extract the rightmost digit by doing modulo 10. So how about I do this here? If I do digit equal n modulo 10, I will get the 4, right? Because for this particular case, parameter is 234, so if I do modulo 10, I will get the 4. Next, I will print the digit. Print the digit, which obviously means I will print the 4 as well. So that's the little bit of work that we've done in this iteration. So let's think about this recursively. What remains to be done after I printed the 4? What remains to be done is printing 3.2, which, if you think about it, is printing 2.3 in reverse, right? Remember this function, print in reverse. So after I'm done printing 4, if I call the same function on this parameter 23, what's it gonna do? It's gonna print 3.2 in reverse, which is exactly what you see here. So we have successfully formulated this. Into a recursive problem. So in other words, I can say p of n, print rightmost digit of n, and then do p of n over 10, right? That's exactly what you see here. So find the rightmost digit and call p on n over 10. That's how you get rid of the rightmost digit, by doing over 10. And that would be it. I probably don't need to put any action here. So to develop our example further, let's follow on with p23. p23, digit is n mod 10. Now this will give me the digit 3. I will print the digit, which will print me 3. And in the same way, I'll do n over 10. This will be 2 this time. Right, so now this will get me up to here. And I can see the remaining problem is print 2 in reverse, which is just 2, which will be exactly what I want. Let's follow on with this. So p of 2 and modulo 10, which will give me 2. Print digit, which will print 2. And what should we do now? There are a couple of things we can do. One thing we can do is we can stop here. And the way to characterize this is because I have only one digit, I print it and I stop. So that means if you got one digit left, print it and stop. Or I can let it go one step further. So if I do one step further, n over 10, now it will be p of 0. And what do you think should happen here? We really don't want 0 to be printed, right? We want to print 432. So this will be my base case, and this will be return, right? So this is the base case. So let's put this whole thing together. What we did here was right for all of these. So print the rightmost digit, do a recursive call n over 10, but I would like to add the base case. Usually we add it at the start. If n is 0, return, which means do nothing. Else continue and do the remaining task. So this is our recursive formulation. When I write the code, that's exactly what I need to put in the code. So print reverse n. If n is 0, do nothing. Otherwise, print the rightmost digit and call the same function on n over 10. So once we move to the code, this will be the piece of data or logic that's gonna go in there. So one thing that would be worth mentioning here is the way we formulated this problem. What's it gonna do for n equals 0? You can trace it. If n is equal to 0 in the first call, right? In the first call, if we call this with 0, it will not do anything. It's not gonna print it in reverse. So it doesn't work for 0. But to keep things simple, I'm just gonna ignore this for a moment. So it works for any number from 1 and upwards, but not for 0. You would have to modify it. It is possible, obviously, to do this. All right, so let's transition to the code. Here we have a empty code, works, compiles, so that's a good start. This is the prototype. This should be a void because it doesn't return anything. It's just print. Let's call it print reverse. Takes an integer. We don't really need to call it. Just mention it's an int, right? No need to write n or anything. That's the prototype. Let's write the function down here. So we're gonna extract the digit. Here's our variable. Remember, in the coding part, we write the base case first, right? So let's do this here. If n equals 0, do nothing, return. Otherwise, we need to do these two guys. Get the rightmost digit and print it. Digit is n modulus 10. Printf. Let's add the space, right? We wanted to get a space, so this is a space. And a recursive call on n by 10. Print reverse n by 10. Notice that this function is void, returns a type void. So when I call it, I don't need to say return print reverse. I can just say print reverse, right? If it returns something, then I would say return and that thing. So, and finally, to end this, I will put return, which means we're done with the function. We can omit that, but usually it's nice to have it in here. So I think that's it for the code. Let's double check one more time. It accomplishes what we had here. Base case, if n is 0, do nothing. Otherwise, get the rightmost digit, print it, put that space, and then recursive call on n by 10. Remember that we call this tail recursion, because the last thing we are doing is a recursive call, right? There is no code after, so that's a tail recursion. If you put this up there, this will be a head recursion. So that's a tail, turn out to be a tail recursion algorithm. All right, so testing this should be straightforward. All we have to do is declare a bunch of variables. Just one variable, right? Int n. Let's change this. Enter integer. Goes in here. And call the function. We don't need to print anything, right? Because the function is gonna print the number in reverse. So I guess that would be it, right? Get the integer from the user, call the function. All right, let's give that a try. 23 works, prints in reverse, separated by space. Let's put a big number in here. Works fine. Um, 123 million, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 100 million, you can do that with integer. Integer, you can go up to billion. So, all right, works. Let me put zeros in the middle, because sometimes when you have zeros in the middle, they mess up the code. Works for zeros in the middle. That's good. Let's put number with all zeros after that. Works again. All right, so I think this is fair enough. Let's put a single digit. Works. The only case we said is not gonna work for 0, because it's gonna think this is the base case on the first try and print nothing, which indeed is what it did. We're ignoring negatives. We assume it's not gonna be used with negatives. All right, so I think this is fair enough for this recursive formulation in the code and the test. What we're gonna do next is we're gonna trace it. So often it's a good thing to trace it on a piece of paper, so you can really understand how it works step by step. So let's move to here and trace it. So that's what we're gonna do. Let's call this guy with parameter 789. So remember how we trace recursive functions. We're gonna write multiple instances, right? Because this function will be called 3 or 4 times. So we're gonna write this function 3 or 4 times to see the multiple instances, and finally we will see how it executes. So if we call the function with n equals 789, imagine this n here is 789, what happens? It's not gonna do this. It's gonna do digit equal 9, print 9. Right? And then it's gonna do recursive on 78. Right? N over 10 is 78, and finally it will do return. So this will be the first instance with the original number. So obviously we have something to take care of, which is this call, p of 78, which will be another instance. If p is 78, what happens? It's not gonna be the base case. Get the digit, which this time will be 8, and print it. Call with n over 10, which will be 7, and return. And obviously we have one more call to take care of, or maybe 2 more calls. So which will be p of 7. P of 7, we're not gonna go here. Rightmost digit and print. Rightmost digit modulo 10 will give 7. Print it. Recursive call n over 10 now will be 0. Right? So p of 0. Let's resolve that. This is the base case, right? It's not supposed to print anything. If parameter is 0, the function will simply return. So this is the p of 0. Return. All right. So what we did here is we wrote the 4 instances that will be called or invoked. And what we're gonna do now is trace the flow to see exactly what's gonna be printed. Because I really need to know, is it gonna print 987, or maybe it would print 789, right? I need to trace it to see the flow between these to really know what the output will look like. So here's how this is gonna go. We're gonna start here, go to this guy, this line, and then first thing we will reach print 9, followed by space. So print 9, followed by space. Print 9 followed by space, we're done. And then call this function. So immediately we're gonna leave to here. Let's do this guy here. So 78, we're gonna immediately show up at this spot and start executing the code. So digit is 8, print 8. That's the next thing, will be printed 8 followed by space. P7. Immediately we're gonna go to the P7, keep everything else on hold. So that's the P7. So up here, let's run the P7. Digit is 7, print 7 and space. And then call the P0. Right? We printed the 7, so we're gonna immediately call the P0. P0, that's the trivial case, is gonna return. So here's the question, where do we return to? So here's the rule. If we left at this line, right, we left this function to go here at this line, so this guy will return to the next line and continue, right? So this return is gonna return up to here. Let's do the lines of transition. So this return is gonna return up to here. And what's that guy gonna do? Immediately return. So obviously we came to this function from here, so we're gonna return to the next line. Right? So it's gonna be a series of returns, not just one return. We return to this line, what's it gonna do? Immediately return. We came from here, we're gonna return to the next line. Alright, and we're done. Where is this guy gonna return? You probably call this P function from the main, so this will return to the main. Or you can even call it from another function. Wherever you call it, it will return to the caller, and it will be the final return as far as this recursive function is concerned. So the output looks good, right? We wanted to print the number in return, so if the parameter is 789, it is gonna print 987. So the integer in return was printed correctly. So everything is good with this question. Now, before we finish this, I'm thinking about one thing. What if we swap the order? If we go back to the code, that's where we did our little task. That's where we have the recursive call. What if we take this recursive call and put it up there above the action? What would happen? It won't be a tail recursion anymore, right? Tail means recursion is at the end. So let's remove this comment. Take this guy and simply swap it. And let's run this. It printed the integer in the same order, right? It printed the integer 2, 3, 4, 5 in the same order. It didn't reverse them, but it put the spaces. So what does this really tell you? What this tells you is all the action above the recursion will be done as we go along. As we go along means as we go here to here to here to here. But all the actions after the recursion will be done on the way back, right? So remember, this is how we generated the digit 9, 8, 7, but we printed them on the way back. So I think enough explanation. Let's trace this code. So remember what I did here. I took the print, I took the recursive call, I put it above the printing the digit, right? So let's modify these two guys, or these function calls. That's what I did. I took this guy and I put it above the digit processing, right? The recursive call, and we put it here. Recursive call, we put it here. The base case really did not change, right? So add 0 is gonna trigger 0. So this will be it. So we have our 4 instances ready. What we need to do now is go through it to see the flow and figure out again what's it gonna print. Make sure we understand that. All right, so let's start here. This is our call with 789. Now here's the catch. Remember that as soon as we reach this guy, the first thing is a recursive call. We're gonna leave immediately, right? So we're not gonna print, because as soon as you hit the recursive call, we're gonna leave to spin that call, P78. So these were put on hold. We're gonna take care of them later on when we return. Same thing. First thing, this guy started. It made the recursive call, so we're gonna go here. P of 0, we're gonna go here. And this guy will return. Let's follow the same rule. Where do we return to? We came to that guy from this line, we go to the next line. So here is our return. That return is gonna go here, right? Compute modulo 10, so it will get digit 7, print 7 and space. And then return. We're gonna return to this line, right? We came from here, we return to this line. So here is our return. Here is our return to this line, right? We came to P7 from here, so we return to the next line. It's gonna compute, digit is 8, print 8, and then return. We came to 78 from that guy, we return to this guy, digit equal 9. Return. We'll do modulo 10, get the 9, print the 9, followed by space, return back to the main. So that explains it, why we got the number printed in the same order, right? We got the number printed in 789. That's exactly our trace. Let me do another call here. We got 789 printed in this order. All right, the last thing we're gonna do is just try to kind of put a summary to this whole thing. So this is what I would like to point out, is how we generated the digits. Right, in the way we in the way we wrote our code. Keep that in mind. If the parameter is 789, how did we generate the digits? We kept doing modulo 10, right? This is how we generate the digit. We kept doing modulo 10 divide by 10, modulo 10 divide by 10, right? So we generated the digit with modulo 10, which means modulo 10, we are always generating the digits 9, 8, 7, right? Because we did modulo 10. So we generate the digit 9, 8, 7, right? You can obviously see that here. That's the first call, we'll get the 9, then we get the 8, then we get the 7. So we generated the digits 9, 8, 7. If we put, let's bring this back here to the tail recursion. All the actions before the recursion will be executed as we go along, right? So if I put the action before the recursion, they're gonna be done in the same order. So if I generated 9, 8, 7 and I print them before the recursion, they're gonna print 9, 8, 7, right? I generated 9, 8, 7. If I put the action before the recursion, it's gonna do 9, 8, 7, which is of course what you're gonna see here again. Let me see, 7, 8, 9. Yeah, 7, 8, 9. Sorry. The parameter is 7, 8, 9, right? We generate the digits 9, 8, 7, and we printed them 9, 8, 7. On the other hand, if the things that you put after the recursion, right? the things that you put after the recursion, they will be done on the way back, right? So keep in mind, I'm still generating the digit 987. This didn't change because we're always doing modulo 10. I'm still generating the digit 987. But if I put the action after the recursion, they will be done on the way back. That's why you're gonna see 789 printed out, right? So parameter is 789. We're gonna see we're generating the digit 987, but we're printing on the way back. So you will see 789. So here will be one nice way to summarize this whole thing. Look what we're gonna do here. This is a recursive call, 3 of them. We're gonna do action. We're gonna do action, recursive call, another action. We're gonna do action, recursive call, another action. We really don't need to call that guy necessarily anything, right? So here is my 3 functions. We're gonna call this function first, then this function, then this function, right? So the function is called 3 times. First call, second call, third call. Each function will do this: action, recursion, action, action, recursion, action, etc. So what is the flow of this program? Look what's gonna happen. This is the order of actions. We're gonna start with A1, reach the recursion, and immediately go to A2, to the second call, and then do A2. Once I do A2, I will reach the recursion, and I will immediately go to A3. So once I do A3, this recursion is gonna be the base case and return immediately. So now I can go down to B3. All right, I'm done at B3. Where would I return to? Remember, we left from here. So at this point, we return to the next line, which is B2. Right? After I'm done B2, where do I go to? We came to this guy from this recursion, so we simply go to the next line, which is B1. So what's the summary of that? Right? You can see the summary. Anything above the recursion was processed as we are moving forward, A1, A2, A3. Anything we put after the recursion was processed on the way back, B3, B2, B1. Hence, you can see that, right? Whether I do the digits above or below, they're always generated in the same way, right? 987. But whether you put above or below, you're gonna print them this order or the other order. So this is the way to think about it. And keep in mind, as long as you know how to trace it, you're gonna discover what your code does. And if it doesn't do what you want, you can always fix it. All right, I think this is good enough for this recursion practice.